Okay, hello students. Here, this is lesson number 2.4, pima 142, and the objective of this learning is something to do with something called conditional probability. So we'll try to see what is this means conditional probability. And there are three goals here. You can see compute conditional probabilities, and also you're going to use multiplication rule. So last time we have seen addition rule, and also how do we know two events are independent? The definition here, the formula is conditional probability. So here you can see conditional probability is the likelihood of an event occurring, given that another event has already occurred. So now this looks a little confusing words. We will see with the examples, okay? So it measures how probability of one event changes when we have information about another related event. Now conditional probability of event A occurring given that B has occurred is denoted by probability P, parenthesis A, and there's a bar here, B. And is read as the probability of A given B. And the formula to do is generally probability of A when B occurred is probability of A and B both occurring and divide by. So it's the ratio of B has already, whatever the event occurred is in the denominator, and then on the numerator is the probability of A and B occurring, provided B should not be zero. Now let's take one example and really understand what the heck is this. So here is an example which says that a fair, and this always we've been using this. We have been using this all the time. Same problem. But a fair die is rolled, and the question is, what is the problem? So, what is the probability that the number rolled is 5, and it is already given to you that it is odd? So, there are two events here. One is the number rolled is 5, and the number show rolled is odd. So, we can write two probabilities here. Means, let's see if this is the dice. Okay. So S is always what are the sample space? So all possible options. So these are all possible. Now let's write down an event that let A be, because five starts with F. So I'll try to let F be an event that the number rolled is the the number rolled is is 5. Okay, and O odd starts with O. So the number rolled is the number rolled is odd number. Okay. Now here the number of all possible outcomes is 6. Let's write each of this. And then also we need to write one more thing is let's also write what is F, and number rolled is 5, as well as it is a odd. So we also need to know which one of this. Now let's write down what is this F means here. F is the number rolled is 5. Now in this sample space, the only place is number is 5. So this answer is 5 here. You're done. And this case, the event, the outcomes for odd numbers. The odd numbers there are three of them. So 1, 3, 5. So it is 1, 3, and 5. And then the next is I want to know how many of them are both 5 and odd. And you can see the only number that is common for both event is this 5. It shows up in both the events, so number 5. Now we will also write separately each probability. Now if this is A, what are the chances that the number role will be probability that the 5 shows up? And you can see here there is only one here, so it is 1 out of all possible 6. In this case, the probability that odd number shows, because there are three of them, 1, 2, 3, so it is 3 out of 6. And the probability here, F and 5, as well as, again, there is only 1 here, so 1 out of 6. So the question is asked, find the probability that number rolled is 5 given. So we are going to use the formula. So the formula, the general formula or conditional probability formula. So using conditional probability, the answer is, it means probability of, we want to given that odd, that means we want to know what is the probability of getting 5 showing up. It means 5 means the F, when you already showed, so put a bar and that is O. So what this means is you have a ratio of probability of F and this, and divide by probability of O. See, so just directly the formula, because the formula, if you remember, probability of A when B has occurred is same as probability the B goes down, and the numerator is the one that is common, A and B. So instead of A, I have, in this example it is F. Instead of O, it is B, just in case you are confused. Now let's plug in your answer. F and, so this F and this goes right here. So that is, so it is 1/6 here, and divide by it, and this O, this goes right here. So that's 3 out of 6. Now we can use keep, change, flip. What is that means is, this is the numerator stays the same. Then you flip, uh, change the division to multiplication. And this one you flip. So this is the numerator. This is the denominator. So you flip the denominator as 6/3. And you can see this is 6 divided by 6 times 3. And we can easily cross out, the 6 and you get 1/3 and you're done. So this is all about the conditional probability that, because you already know it is odd, what are the chances that you're going to get 5? You could also use another easy way out called reducing the sample. It is called reducing the sample space, because you already know the number that shows up is odd. And so by common sense, you know these are the 3. And then out of these 3, you want to know the number is 5. So it is 100% has to be 1 out of 3. But then we are going to use this conditional probability formula to this. Let's see the next question. So the second question is asking us is just the opposite. Is find a probability that the number rolled is odd. Maybe you need to know what is the chances that you're going to get, shows this number is going to be odd, and given that it is 5, so you already told. So we are going to use the formula again. The F goes down, probability of F, and the top one is probability of O and F. Now we already know the answer, that O and F, this is O and F here. This will go right here, so which is 1 out of 6. And the F is right here. This will go here, which is also 1 out of 6. And this answer will become, the numerator is 1/6. You write the numerator. Of course, you can directly cancel. Both fractions are the same. So you can just cross out and you get the answer is 1. I hope I made sense to you. Otherwise, also, if you use your common sense, you are told that the number that shows is already 5. Now, what is the chance that it's going to be odd? And we already know 5 is an odd number. So it's going to be uh, it is going to 100% going to be odd. So it has to be, chances that it's going to be odd when you know it is 5 is also 1. Okay, so this question number 2 says, in a sample of 902 under 40 who were or had previously been married, each person was classified according to gender. That means horizontal, you can see this is male and female. This means total of number of males married. this is total number of females married. So all this, if you add these three pieces, that's what that means you add up. And if you add these three pieces, it adds to 452. And this together will be 902. That means out of 902. But the question is, what is the meaning of this E, W, and H? So E stands for those person who these are teenagers. That means teenagers who got married. That means teenagers in the age group, maybe just less than 19 or until 19 years. And when you talk about W is those who got married at the age from 20 to it's like 22 between 20 and 29. And H stands for those who got married at the age first time they got married at the age of 30 and 30 to 40, 39. Or we'll say 40 because under 40, so until 39. Okay, so now the question is so what is this basically means? What so I would like let's understand this basically means let's me take off everything to make sense. So if this stands for those teenagers who got married, that means 43 males who got married at below like 19 years, and females got so many of them, almost double. See, and together is 125 got married during their teens. So that's what that basically means. And what is the meaning of that W basically means? What does this column stands for? That means 293 males were got married at a age between 20 to 29. 292 females got married, almost close. See, this at the age between these two, I think it's almost same thing, and together is 592. And if you go beyond that, the third column stands for. So what is this? So this is called. Actually, this will help us to find what is the conditional probability from the question. But it is really important to understand this each one of this. So H stands for those who got married in the first time from the age 30 to 39. And let's see, this one says 114 male got married, and only few got married at in 30s. That's what that means. And altogether 125. Now the question is what is the question? So find the probability that the individual selected was a teenager at first marriage. That means during his first marriage, he was a teenager. Now, this is a direct question. So look up for so we'll have to look up for the first marriage. That means this piece is first marriage. This is the first marriage. If you see here, it only says a teenager. It does not say male or female. So when you say male, it means all together. So that means I have to write here probability that he is a teenager who got married first time. That means that what is the uh, probability, the ratio, the total number of uh, individuals already give out of 192. That means this is out of 92, and then you are picking here, or you can say, so this 92 is all individual, okay, and the top numerator, how many of them are in the age group in their teens until less than 20, and you can say there are 125. So this is 902. So this is 902. 902, and out of this there are 120. If you pull out your calculator and work on this, you get the answer as 0.139 if you round it to three places like this. Or you can also change it to percentage by moving decimal two places. So it becomes 13.9%. Now let's see What is the next question says? Find the probability. The individual selected was a teenager at first, but he's given that the person is a male. Now, what does this means? If you already know, let me write this answer here. So we are going to use conditional probability formula. And, and what is that conditional probability formula means? Probability that you want to know the teenager first married. Now, first married means E, right? So, what is probability that a person selected is married first, and it is already we know that he is already a male. That means he is a male means here. See, he is already male. So we have to look up for only the let's see. Let me use this is the row that is important for us now. Now that means first write the formula. The formula is probability of E as well as M. That means he's in 20s and he's a male. Divide by probability that he is a male. So this is how we write down. And now let's write the probability. Let me clean this up. Huh. So question is, so let's write the down part first. I'm gonna use this probability of males. So how many males are there? And you can say the total number of males are 450. So out of 450, how many of them that we from here, of course, the total individuals that all total individual is out of 902, and out of 902 probability that is going to be male, basically there are 450 here, so this 450 goes right here. See, then there is a division, right? What about how many are both E and M? So what this basically means, the person is both is is in 20s, that means he is here in 20s, this row column, and he's also a male. So you can see if you go this way, this is the number which says the individual first time when he was married, and there were 43 individuals, and the males were 43. So this 43 students is uh, 43 males were in their 20s. So I want you to understand this basically means 43, they are males, but they are in their 20s. So that means this E and that part E, that means in 20s, and the person is already male. That means this also is out of 902, and divide by, and the numerator is there are 43, so that 43 goes up here. And you can use keep change flip, that means keep the numerator, this is the numerator, so that's 43 divided by 902, and then you flip this is keep change flip, so you keep you change the division to multiplication, and this is the denominator, and which is changed to flip it 9 over 2 over 4 over 50. And then you can just cross out this 902 is the same, and you get 43 divided by 450, which we can use a calculator, and you can get the answer 0.096. So rounded to 3 places. Or you can also say, hey, that's like if you move decimal 2 places, that's like 9.6%, or you can round it to also 10%. So as long as you write this answer, this is what matters. I hope you have understood this question, but let's make another question. Let's see what is the probability that a person is married late 20s, that means late 30, and given that that the person is female. So we could do this way also. I can put a question. I hope that means this means probability of H and female. That means person married late 30s and a female, and probability that she's a female. So this could be another question. See, and we can also write directly here. First of all, um, you can see basically the ratio that you see is the total. That means you know already last problem there were 450 males, so it's kind of from 450 you select this number. So can we use the same idea here also? But I don't want you to get confused. Let's do actual formula, the probability thing. So this is the division, and the denominator, the probability of a student is a female. That means we have to see this row, and then how many females are there? 452. That means there are 452 divide by 902, and the top part will be both female as well as married in late 30s. That means you have to go for this column here. This column, you can see this is the number that is 71. That means 71 out of 902. Now both they have the same common denominator. So because they have the same common denominator, we can directly write this keep change flip if you want, or you can just cross out this 902. They are both denominators suggested, and you get 75 out of 452. I hope I made sense. So the okay, so this one is example number 3 says suppose in an adult population the proportion of people who are both overweight, so this is very important, overweight, and they and suffer hypertension is given to you is 0.9. Now, what that means is let's write down O stand for a person selected suffers from uh, person suffers from or over person is overweight. Let's write shortcut. A person is overweight. So O stands for person is overweight, and H stands for a person selected is suffering from hypertension. So I'm using shortcut here, hypertension. Now that means if I write H complement, now what is H complement means? Not suffering, not suffering, not hypertension. That means a person is not suffering from hypertension. And if I write over age to C, this means not overweight. So this means not overweight. So these few things should be understood. Now using this, we can do a two-way contingency table. Now what is two-way contingency table basically means like this. So we can think of a person suffering from hypertension and not suffering from hypertension. A person who is overweight and who is not overweight. So this is like kind of organizing the data. So what does this says is a person who is overweight and hypertension, the probability is given to you as 0.9. That means if you see in this example that I showed, this way, this row is person who is, and also hypertension is given to 0.09. So this is this. So what that basically means, probability of O, and he's also suffering from hypertension. This is 0.09. Now basically it is out of 1. This means it is out of 1. Of course, it is 9 out of 100, which is 9% kind of a thing. So right now, I'm going to fix only this one. Then the next is, what is the next information? So the proportion of who are not overweight, so not overweight will be, this one is not overweight, but suffer hypertension. So suffer hypertension. So this is given to you 0.11. Next is given to you is the proportion of people who are overweight. So they are overweight. So they are overweight and they do not suffer hypertension. That means it is this one. So that is 0.02. Okay. And also the last one who are neither overweight and no nor they are hypertension. That means this one, not overweight and no. So this is organizing. Now we want to know from here, the question is asked, find the probability that a person selected suffers from hypertension. So this is very nice problem. So probability that a person is selected and he suffers from hypertension, he is suffering from hypertension, but it is told to us, given that we are overweight, so it is W. And by formula, what does this mean? It is probability person who suffers both hypertension and overweight and divide by probability he is overweight. All you do, look up from the table and so let's do the bottom piece first. What are the chances, the probability that a selected person is overweight? Now, altogether, this is, you have to say how many overweight, right? So this is overweight. Let me use the red color and I have to use here. So this will be, I have to use these two pieces, which will be, if you add, it will be 0.11. So basically you're adding 0.09. That means the first one and you're adding to 0.02 and then divide. Oh, sorry, this should be down because that's like all together. I'm so sorry. So this should be 0.09 plus 0.02. And the top part is how many are suffering both from hypertension and overweight. This is overweight. This is overweight. Okay. So that means so I by mistake I wrote W. W means weight, right? So overweight. And the top one means you can see from the table that this number is the one that is overweight. So this is overweight, and this is also suffering from hypertension. That is 0. Oh, I already have this piece here, 0.09. Okay. Yeah. And if you use the calculator, of course, we can write this is 0.09 divided by 0.11, and the answer will be, if you do use the calculator, 0.8182. Okay, so this is probability that H, given that he is overweight. So this piece I'll put in the let's put this in important information. So this is the A part. What is the B part? Is what is the probability that uh, that a person is overweight, suffers from hypertension, given that he is not overweight. You see this piece is not overweight. It means he's suffering from hypertension, but it is told that that person is not overweight. So in this case, what we will do is the formula goes the same. Probability of the down one will be probability of not overweight, probability of hypertension, and so this is how that conditional formula helps. Now, if you see the denominator, we have to look in the table. This one, not overweight. So how many are not overweight? And you can see we'll have to add here. These two pieces will have to add 0.11 plus 0.78, and that will be adding up. I think it is adds to 9. 9 So that is 0.89 there. Okay, so that will be, uh, so this number will go 0.11. So because this number that you see is both suffering from hypertension, and he's also the not overweight, so which is 0.11. So this will be 0.11 divided by 0.89. This is 0.89, and if you calculate, use the calculator, you get 0.1236. Round it to 4 places, and this is probability of hypertension but not overweight. So we can easily compare that which one is more, which one is. So question is asked, C, compare the two probabilities just found to have to give an answer to question as to whether overweight people tend to suffer from hypertension. Now, if you look in the table, if you look at this table, overweight people, if you see this, these are overweight people. Overweight people is 0.9 suffering from hypertension shows, and overweight people not suffering is. So if you look at these two numbers are, what I'm trying to say here is, I think we'll have to, these are the hypertension. This is important. If you look at this number, hypertension and overweight is 0.09, and hypertension and not overweight is zero point 0.1, which is now 0.09 is almost the same as 0.1. So one leads us to wrong conclusion to say, hey, it doesn't matter whether you are overweight and not overweight, you will have hypertension. But that's not what this answer shows us. This answer shows us if you are, so that's why this really have, if you are overweight, then the chances that you'll be suffering from hypertension is of 0.82. And if you are not overweight, then the suffering from hypertension is very less. It means almost 7 times more. This number is almost, if you see, 0.8 is a large number, 0.1 is very small number. So almost 8 times. So that's the understanding of this formula problem. Okay, now the next problem is this one. It says a table shows the number of survey subjects who have received and not received speeding ticket in the last year and the color of their car. What is the probability a person is selected? So this one gives you a two. So this is called two-way contingency contingency table. So the red car and not red car. So they already give you red car, not red car. So this could be R, this is complement, and this is the total red car, the total red car. And this is the speeding ticket. Let's see, we put ticket T, and this could be T complement. Now the question is asked. First question is asked. Find the probability that a person chosen has a speeding ticket. So what does this basically mean is probability that he has a ticket. So I'll just put T when it is already told given. So this is what is given that the car is red. So this is how you write. So conditional probability that you already know the car is red. So all you do is make a ratio. R goes down. So probability of R. And the top one is both T and R. Means person got a ticket as well as his car is red. Now we'll put the denominator first. What is the chance that the probability that when you select he has a red car? So how many red cars are there? See, so these are total red car. This is total red. So these are red car total. That means there are 150. So 150 red card, but out of how much? So 150 red out of 665. So this is 665 is the total number of person a survey was being done. So that will be 650. And the next is whether it is the next is again out of 665. We want to know how many of them were both. Now this is the time you have to select both uh, ticket as well as, so this is T and R. So T is this one, this is the T, and R is this, and you can see this is the one that represent both. Person has a red car, is a red car, and he also got a ticket last year. So that's 15. So 15 out of this. And you can see 665 is the same. So if that is the same, you just write 15 out of 150. So 15 out of 150 is same as 0.1, which is almost 10%. So you answer, if you write this, you're done. If you write this also is correct, 10% also is correct. And the next question is, what is the problem? So this was the A part, and the B part is probability that uh, has a red card. So it has a red card, and given that he got a ticket, so this is just the opposite. So now T goes down, probability of T, and the top one is almost the same. This piece is the same, but I'm gonna write R and T. So the bottom part is ticket. So for this, I have to select how many total got ticket. So the total got ticket is this 60. Can you see? This is the total 60. 60 out of, so these are 60% got a ticket out of 600. So this is relative probability, that means relative to 665. That's why. In the numerator, this black color, so this will go right here. It is the same. Sorry, yeah, 15 out of 665. So again, you can cross this out and you get 15 out of 60, which will be 0.25. You can see, and which is like 25%. I hope I made sense to you. Like really nice problem to understand that. So what does this mean is probability is if you have a ticket, that means the chances that your car is red is 25%. And if you have a red card, then the chances that you're going to get a ticket is going to be is 10% only. So this is the understanding. So let's move to the next question. Okay, finally we go to what is the meaning of general multiplication rule. Now the general multiplication rule is almost the same as the one that we already know, conditional probability. So the conditional probability that we knew is probability, let's see, probability of B when A happens. It means, what does this means is the probability of A, and then the top one is probability of A and B, or B and A means one and the same. So this is the main conditional probability, where if you multiply by both sides by probability of A and you multiply probability of A, what you end up getting is this probability of A and this crosses out, and you end up getting probability of, so this I'll write here. So probability of A and B is probability of A times probability of B when A has occurred. So see, and that's what you see in this example. Only thing I like to write this here and this here. This is always better. Or in other words, probability of, let's see, A and B, there are two ways you can write. One is if A has already occurred, so that's like probability of A. and then times probability of B when A has occurred. So this is one way. You can also write this formula as probability of B times probability of A when B has occurred. So these are called multiplication rule of probability. So these are multiplication rule, and see how we can use this multiplication rule of probability. Let's see, take an example. So here is an example. If you pick two cards from a deck of cards, if you pick two cards from a deck of one after another and keep both, then what is the probability that both are spades? So I can write spades. A is that first card is spade, first card spade, and B is the second card is spade. So what we want to know is probability of that A and B. Okay? So we can write either of the formula. That means it is probability of A times probability of B when A occurs. Now, to answer this question, the probability both are spades. The first one is spade, the second one also is spade. Now, if I want to write here, let's write what is probability is that the first card is spade card. And the probability for the first card is spade card is, since there are 52 cards, okay, and spade card there are 13 of them, so that will be 13 out of 52. So this will be 13 out of 52. And the next question says, what is the probability that uh, that that you already know? That means here, uh, so what does this means? Now this is slightly different. That means you are being told that the first card is already ace card. Okay. Now from the deck of cards, so if these are all cards, 52 cards, and one card is already taken from spades. So from 52 cards, one of them is already taken spade cards. It means what is left is now you have no more 52, but you have 51 cards, and there will be, since one card is spade is taken out, so there will be remaining will be 12 spades cards. See, so that means this part is probability that means out of 51 cards you're selecting, and you are choosing 12 cards. Okay? So this is how it works. So this will be, if you do a little of math here, if you multiply the numerator, you get 156 over 2652, and then using the division, you get 0.0588, and you're done. I hope that helps to know how do we apply the multiplication rule of probability. So next question is saying, if you draw two cards from them, what is the probability that you get an ace of diamond and a black card? Now this is, let me write it here nicely. So probability that you get ace of diamond and a black card. So now this could, you have two options here. This could be, well, let's see, this could be probability that the first is diamond card, diamond, and second card is and second black card, or so I'm gonna write plus, because you have two options, case one and case two. It could be probability that the first card black, and the second one is ace of diamonds, and second card is ace of diamonds. So each time we'll use multiplication rule of probability. So this is that event like A, this is that like B. So if I want to find out, let's see here, so this will be probability we can write probability that the first is ace card times probability that it is a black card. The second one is black. When you already know the first is ace card is plus, and another way to do this is probability that the first is black. So I'm using this one as black times probability that it is the second is ace of diamond. When you know that the first one is black. So first ace card, ace of diamonds. So how many ace of diamonds are there? So there's only one card with the ace card, which is a diamond card. So that means you can select one out of 52. And then after that, one card is already gone. So the remaining card that you have is 51 cards. And you want to have them black, right? So that means there are 26 black cards. So this is 26. Plus, next is this piece. First is black card. So that means the first card can be 26 out of 52 times. And the second is ace of diamond. That means you are remaining with 51 card. And ace of diamonds, because this black card cannot be a diamond, right? So all ace card will be ace of diamonds. So this is the ace of diamond here. So that's the ace of diamond. There are four of them. There's only one diamond. So what are you getting is if you do this, it is 26. So if you see this 26 divide this by 2 times, and you will get 1 over 2 times 151 times 2 is 102 plus again the same thing. This 26 goes 2, so it is 2 times 51 102. So it is both are same. So you get 2 out of 2 times 1 over 2, so which is 2 out of 102. If you divide by 2, get 1 out of 51. So that's the answer. The probability that you get ace of diamonds is so less. So I hope I'm making sense to you. So 5.2 in your drawer you have 10 pair of socks. So if this is a drawer here and you have 10 pair of socks inside, so you have 10 pair of socks. This is 6 pairs are white. These are 6 white. That means there are the remaining are non-white. So let's put blue as non-white. So I'll write non-white, 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 non-white. 4 of them. Altogether is 6, 10 of them. So the question is 6 pairs are white. If you reach in and randomly grab 2 pair of socks, so what is the probability that both are white? So you want to know probability the first one white, first white, first white. So we can say and the second one, second white. So that means this means it is probability that first white times by using multiplication rule of probability. The second also is white when you know that the first one is white. Okay. So that means the probability that the first one is white, it means there are 10 of them. So out of this there are 6 white, and once one white is already taken off, there will be 9 remaining because so you already know that the first one is white, so there will be 9. And out of this white, one of them is gone, so there are 5 of them remaining. So it is 5 out of 9, and you get answer as 30 divided by 90, and you can see 3 out of 9, and you're done. So that's all this question says. But you could have also selected that in using also another way is directly there are 10 of them, you are picking up 2 and the order matters. You could use even this also, and probability that the first one you are picking 6 P1, and once you do that, you do the remaining out of 5 P1. So you are using the numerator, you can use fundamental principle of counting also. But if you this is how you can use permutations also and do because the order does matter. Because the top part will be this will be 6 times 5, and this will be 10 times. It's almost the same thing, and you get the answer, same answer. So this means the first one is picking first one out of 6 white, and then after that you have a 5 remaining, and you pick the another one which is going over the 1 out of 5. Question number 5.3. This question I have a separate video. I already read video link poster. I will attach it. It is in my YouTube channel somewhere in my other class when I was teaching. I made this video. It's a big, nice rigor problem. A lot of maths there to understand how to use multiplication rule of probability, addition rule of probability, also complement rule of probability, and also conditional rule of probability. So a lot of stuff there. So please wait, you can complete from this. This link will be given, okay? Let's go to the next question. So this is another concept. What is the meaning? Independent event basically means whenever probability of A, when B happen is probability of A. What this means is when A and B their probabilities do not get affected by each other. Whatever situation occurs for here, probability A and probability are both independent. It means one does not affect. It's like if you roll a coin here, whether you get head and tail does not have nothing to do with if you have a if you roll a dice. So these two things are independent. See, these two are independent. Or it could be a deck of cards also. What you pick a card here, nothing to do with the rolling a dice. Let's take an example. So this is by formula. It means this formula reduces to if you have probability of A and B by multiplication rule of probability, it is probability of A times probability of B when A occurs. Now, when A occurs has got nothing to do with you end up getting this piece, this piece goes away, and you just write probability of B. So when probability of A and B is same as this, then we say it is an independent event. So let's take a simple example, a roll or die. If you roll a die and it is 3, and B is it is 1, 3, 5. Are these independent? So all you do is what is probability of A here? And probability of E, you can say there's only 1 out of 6. And what is probability of B? And probability of B is 3 out of 6. Okay. And next is we want to know what is probability of what is probability of A when B occur. Okay. To find out this, because this formula is probability of A and B, divide by probability of B, but we need to know the numerator is probability of A and B. So how many are there in A and B? It means what is common here, and what is common here is the 3, right? So that this is that A and B, which is only one, a single piece. So it is 1 out of 6. So now we'll plug it in here, and you can see this piece when you go, you put 1 over 6. This you put down, and you get to keep You get this, then you keep change flip, or you can very well cross out and get 1 over 3. And this 1 over 3 is also probability of A. Sorry. So this space probability of A when B happen is not the same as this. See? They are both different. And that's why if you get confused, another way to show if you don't understand this, what I showed, you can also use directly what is probability of A and B. So this is probability of A and B. And what is probability of A and B? Uh, so we is already 6, right? So let's do multiply probability of A times. So A is 1 by 6. And this answer is 3 by 6. So that is like 3 out of 36, which is 1 by 12. See? And this 1 by 12 is not same as this. And that's why I say this is not independent. So example number 7 is many diagnostic tests for detecting diseases do not test for disease directly, but for chemical biological product of the disease. Hence, are not perfectly reliable. Sensitivity of a test is probability that the test will be positive when administered to a person who has the disease. The higher the sensitivity, the greater the detection rate, and the lower is false rate. Now, suppose the sensitivity of a diagnostic procedure to test whether a person has a particular disease is given to use as 92%. So that means when the person is tested that he has a disease, test positive. So this is test positive. So when a person really has a disease and he goes to check, his chances of getting test positive will be 92%. That means 92 out of 100. Or which is, of course, I'll just keep it 0.92. Okay. Then a person who is actually has a disease is tested. It is using this procedure by two independent. Now there are two independent. Suppose these are the two independent uh, mm, clinics where they do check the testing, and both of them they do. Now see, whatever the test done here doesn't have nothing to do with the test here. So what we want to check, what is the probability that both test positive? So probability that the first clinic test positive and second test positive. So the answer become by multiplication rule because they are independent, because these two are independent. Right? So we can write and the first one positive is given is 0.92 times second one. So you just multiply these two answers and you end up getting point. So you get 0.8464. Okay, which is almost like 84.64%. And the second question says, so let's clean this up. The second question is, what is the probability that at least one of the two tests results in positive? What this means is, probability is at least one test positive basically means at least either this or one of the tests is positive. Is same as saying it's like probability of A union B. See, A union B is probability of A plus probability of B minus probability of A and B. So this basically means probability is that the first clinic positive plus probability the second clinic is positive minus probability both positive. A first positive and second positive. So that means first positive is given to you 0.92. Second one is positive also is 0.92. And both positive we got from the previous problem answer was 0.8464. And you get this answer very high percentage that the person will be tested positive. I hope this makes sense. Now, instead of saying this word is used here, sensitivity, and another way to write this opposite word is called, they use another word called specificity. Specificity, speci, specificity. Okay, crazy word. It basically means suppose it's checking the probability of a person does not have disease and it tests negative. So almost the same idea. We'll see that question, last question. So what does this basically means? A specificity of a diagnostic test is the probability that a test will be negative when administered to a person who does not have. See, the higher specificity, the lower false positive rate. So the question is, suppose the specificity of diagnostic is already given very high, say 89, which is 0.89. So it means that if the person whoever goes for checking, actually he does not have no disease, or he doesn't have disease. So chances that the clinic does the test and he gets false. That means the clinic really shows that he does not have a disease. So that's what that 89% basically means. Now, a person goes and does the test. Okay, a person who does not have disease is tested for using procedure. What is the probability that the test will be positive? So probability that test is positive. Okay, since our question is, it talks about negative. See, so this is specificity basically means negative test, right? So it's opposite of, so it is 1 minus probability of test is negative. Test is negative. So this is that test is negative, right? So we have to write down 1 minus 0.89. If you do little maths, I get 0.11 and you're done. Now if you go to a person does not have uh, he does not have disease, but he goes to two separate laboratories like last time. What is the probability he tests both positive? That means this means probability he goes first positive and second positive. So this means probability, because there are two independent clinic, you can write first positive and second positive. That means this is still can be written as 1 minus, which is the first one positive. We have already found the answer. See, test positive is 0.11. So we can write 0.11 times 0.11. And if you multiply, you get 0.0121, which is like 1.21%. So I hope that helps.